The electronic configuration of four elements A, B, C and D are: A is equal to 1s2, B is 1s2, 2s2, 2p2, and C is 1s2, 2s2, 2p5, and D is 1s2, 2s2, 2p6. The tendency to form electrovalent bond easily किसकी है इसमें से? D, C, B और A. The right option is more electronegative element, more ionic bond quickly. So C is the right option. The halogens with the highest value of ionization energy is F, fluorine, chlorine, bromine or iodine. Due to small atomic radius, fluorine have high ionization energy, so F is the right option. Which of the following has highest electronegativity? Iodine, bromine, chlorine or fluorine? Fluorine is more electronegative, so that's why fluorine is the right option. The order of electron affinity of halogens is electron affinity order of halogen is chlorine is greater than fluorine is greater than bromine is greater than iodine. So third option is the right option. Which of the following shows greatest inert pair effect? Fluorine, chlorine, bromine or iodine? Down the group inert pair effect increases, so iodine is the right option. A substance that sublimes readily is fluorine, chlorine, bromine or iodine. The right option is iodine sublimes, so iodine is the correct option. Halogens are colored because their atoms have high electronegativity, their molecules are held together by weak van der Waals forces, their molecules absorb visible light causing the excitation of outer electrons to higher energy levels, their atoms absorb energy causing the excitation of outer electrons to the higher energy level. Halogens absorb visible light causing excitation of outer electrons to higher energy level. So third option is the right option. Which of the following halogen has highest bond dissociation energy? Fluorine, chlorine, bromine or iodine? Chlorine have the highest bond dissociation energy. So second option is the right option. Fluorine does not show variable oxidation states due to high electronegativity, small size, low bond dissociation energy, non-availability of d orbitals. Fluorine does not show variable oxidation state because of the absence of d orbitals. So fourth option is the right option. Which element would readily replace oxygen from an oxide? Fluorine, chlorine, nitrogen or sulfur? Due to the more electronegative, fluorine replace oxygen from oxide. So fluorine is the right option. Which of the following compounds has the lowest boiling point? HF, HCl, HBr or HI? Due to the low molecular weight and absence of hydrogen bond, HCl have the low boiling point. So HCl is the correct option. Which of the following has the highest percentage of ionic character? That is HCl, HCl, HF, HBr or HI. The right solution is due to the more difference in electronegative, HF has the more ionic character, so HF is the right option. Which of the following hydrogen halides that's thermally stable is HF, HCl, HBr or HI? The correct option is down to the group thermal stability decreases, so HF is the more stable. Which of the following does not form precipitants with the AgNO3? HF, HCl, HCl, HBr, HI. HF do not give PPT with the AgNO3, so HF is the right option. Fluorine is more reactive than chlorine because FF bond is weaker than SC. Chlorine bond. Fluorine does not have d orbitals. Fluorine has high ionization energy, or electron affinity of fluorine is lesser than that of the chlorine. The right option is fluorine. FF bond is weaker than chlorine bond. So first option is the right option. Which of the following has the maximum vapor pressure? HCl, HBr, HI or H2F2? Due to the low boiling point, HCl have the high vapor pressure, so HCl is the right option. Which of the following will result in the oxidation of halide ion? Cl2 pass through aqueous NaCl, I2 added to aqueous HI, Br2 added to aqueous NaF, F2 added to aqueous HCl. Lighter halogen displaces the heavier halogens from their aqueous halides. Then when F2 added to aqueous HCl, Cl negative ions replaces. So fourth option is the right option. Which of the following form are interhalogen compounds? Fluorine, chlorine, bromine or iodine? Interhalogen compounds, all of the above. All the halogens form interhalogens compound. So fourth option is the right option. Which of the following is known as a superhalogen? The superhalogen is chlorine, bromine, iodine or fluorine. So the right option is fluorine is known as the superhalogen. So third option is the right option. The halogen forming largest number of interhalogen is fluorine, chlorine, bromine, iodine. The halogen forming largest number of interhalogens is F2. F2 forms more number of interhalogen compounds, so F is the right option. Halogens which show metallic character is fluorine, chlorine, bromine or iodine. The halogen down the group metallic character increases, so iodine is the halogen which shows metallic character is iodine. So the fourth option is right option. Halogen which shows metallic character is fluorine, chlorine, bromine, iodine. Down the group metallic character increase hota hai, that's why iodine is that answer. Halogens, haloethane is CF2Cl2, CF3, CHClBr, C2F4 or all. Haloethane is known as a CF3CHClBr is known as a haloethane. order of volatile nature of halogen is gradually decreases from F2I2, decreases from F2 to Br2, but then increases, gradually increases from F2 to I2, increases from F2 to Br, and then decreases. The right option is down the group volatile nature of halogens decreases. So first option is the right option. In order of bond energy of halogen is, the bond energy order of halogens is Cl2 greater than Br2 is greater than F2 greater than I2. So third option is the right option. The number of unpaired electrons and lone pair of electrons in the first excited state of chlorine and in its valency shell, that is 2 and 2, 3 and 3, 2 and 3, or 3 and 2. The right option is the first excited state of the fluorine. Number of unpaired electrons and lone pair electrons are 3 and 4 respectively. So fourth option is the right option. Hybridization of central halogen atom in XX-7 type molecule is sp3, sp3d, sp3d2, or sp3d3. The solution is XX-7. The central atom involves a sp3d3 hybridization. So fourth option is the right option. The order of reactivity of halogens with hydrogen is, the reactivity order of the halogen is flow F2 greater than Cl2 greater than Br2 greater than I2. So second option is the right option. At ordinary temperature and pressure, chlorine is a gas, bromine is a liquid, iodine is a solid. This is because of these three, chlorine is the lightest, iodine is the heaviest. Chlorine has lowest specific heat. Chlorine molecule is the least stable, or intermolecular forces are weakest in chlorine and strongest in iodine. The solution is down the group intermolecular forces of attraction increases. So Cl2 is a gas, Br2 is a liquid, and I2 solid at a temperature, ordinary temperature. So the fourth option is the right option. Halogen molecules are diatomic to form X2 2 ions, diatomic to form X negative ions, monatomic and form X2 2 negative ions, or monatomic to form the X negative ions. The right option is halogen molecules are diatomic and form X negative ions. So second option is the right option. Iodine is liberated when chlorine is passed through the acidified solution of potassium iodide, because Chlorine is powerful reducing agent than iodide. Chlorine is powerful oxidizing agent than iodide. Chlorine is more electronegative than iodine. Chlorine is less electronegative than iodine. The right option is chlorine is powerful oxidizing agent than iodine. So, second option is the right option. One gas bleaches the colors of flowers by reduction and the other by oxidation. The two gases are respectively Cl2, SO2, H2S, Br2, SO2, Cl2 or NH3, SO3. The solution is SO2 on reduction bleaches colored matter due to reduction. Chlorine bleaches colored matter due to oxidation. So SO2 and Cl2 is the right option. Which of the following is most stable to heat? HCl, HOCl, HBr or HI. The right option is HCl have more bond energy, so HCl is more stable to heat. So first option is the right option. On boiling an aqueous solution of KClO3 with iodine, the following product is obtained: KiO3, KCiO4, KiO4 or KCi. The right option is K2KClO3 is plus I2 is giving you 2KiO3 plus Cl2. So KiO3 is the right option. At room temperature, F2 reacts with all non-metal except BNC, SNBr, H2NTE, O2 and N2. The solution is at room temperature F2 react with all non-metal except O2 and N2. So fourth option is the right option. Bad conductor of electricity is H2F2, HCl, HBr or HI. The right option is due to the absence of free ions, H2F2 bad conductor of electricity. So H2F2 is the right option. Which member of halogen family does not show positive oxidation state? Fluorine, chlorine, bromine or iodine. Due to the more electronegative in halogen family, F2 do not show positive oxidation state. So, fluorine is the right option. The element which exists in the liquid state is bromine, mercury, gallium, all. The solution is Br, Hg or Ga exists in the liquid states. So, all is the right option. As the atomic number of halogen increases, the halogens lose that outermost electron less readily, become lighter in color, become less denser or gain electrons less readily. The solution is as atomic number increases, tendency to gain electron decreases in halogens. So, fourth option, gain electrons less readily is the right option. A solution of potassium bromide is treated with each of the following. Which one would liberated bromine? Hydrogen iodide, sulfur dioxide, chlorine or iodine. K2 KBr plus Cl2 is giving you 2 KCl plus Br2. So the chlorine is the right option. Which of the following pairs is not correctly matched? Halogens, which is liquid at room temperature, bromine. The most electronegative element, fluorine. The most reactive halogen, fluorine, or the strongest oxidizing halogen is fluorine. The strongest oxidizing halogen is fluorine. So this is not correct. So the right option is 4. Hybridization of IF7 is sp3d3, d2sp3, sp3d, sp3. In IF7, hybridization is sp3d3. So first option is the right option. Mark the halogens that does not have disproportionation reaction with alkalis. That is fluorine, chlorine, bromine or iodine. The right option is the element which exhibit more than 2 oxidation states can undergo disproportionation reaction. But fluorine have only 2 oxidation state, that is 0 and -1. So fluorine is the correct option. Which of the following is red colored liquid at room temperature? HCl, HBr, Cl2 or Br2? Or at room temperature, Br2 is reddish brown colored liquid. So Br2 is the correct option. Halogen atoms have high ionization energy, high electron affinity and low electronegativity. High ionization energy, high electronegativity and high electron affinity. High ionization energy, low electron affinity and high electronegativity. Low ionization energy, high electron affinity and low electronegativity. Halogens have more electronegativity, high ionization energy and electron affinity. So second option is the right option. Fluorine differs from rest of the halogens due to its high electronegativity, smaller size or lack of d orbitals, low bond dissociation energy, all of the above. The right option is all of the above. In dilute aqueous solution, HF is weaker acid than HI because HF bond energy is greater than HI bond energy. Hydration energy of fluorine is higher than the iodine. Of the presence of hydrogen bonds is in HI. Fluorine is a stronger base as compared to iodine. The correct option is HF bond energy is greater than HI bond energy. So first option is the correct option. Boiling points of hydrogen halides increases regularly in order to relative molecular mass, decreases sharply from HF to HCl and then decreases regularly in order to relative molecular mass, or increases sharply from HF to HCl and then decreases regularly with increase in relative molecular masses. The right option is in HF hydrogen bonds are present, so it has high boiling point than HCl. From HCl onwards with increases in the molecular weight of hydrogen halide, boiling point is also increases. So second option is the correct option. The order corresponds to which of the following properties? Bond length, thermal stability, ionic character, dipole moment. The order of bond length is HI, HBr, HCl, HF. So bond length is the correct option. Amongst the following, the one which is capable of existence is KHCl2, KHF2, KHBr2, KHI2. KHF2 is exists by because the formation of hydrogen bond, so KHF2 is the correct option. Which of the following halogen has more bond energy? Fluorine, chlorine, bromine, iodine. Bond energy order is Cl2 greater than Br2 is greater than F2 is greater than I2. So chlorine is the correct option. The correct increasing order of the bond dissociation energy for N2O2 F2 Cl2 is. The correct option is F2 is less than Cl2 is less than O2 is less than N2. The halogen which is most easily reduced is F2, Cl2, Br2, I2. Fluorine acts as the strongest oxidizing agent, so it is easily reduced. So F2 is the correct option. Fluorine is better oxidizing agent than Br2 is due to small size of fluorine, more electron repulsion in fluorine, more electronegative of fluorine, non-metallic nature of fluorine. The right option is more electronegative of fluorine. Ozonized oxygen can be obtained from H2O by the action of concentrated H2SO4, KMNO4, MnO4 negative, F2. Then the mixture of O2 and O3 is called ozonized oxygen. So 2F2 plus 2H2O giving you H4HF plus O2. That means 3F2 and 3H2O giving you 6HF and O3. So F is the correct option. Which of the one following elements can have both positive and negative oxidation state? Fluorine, chlorine, iodine, lithium or helium. The right option is due to the presence of empty d orbitals, iodine has the both positive and negative oxidation state. The correct order of increasing oxidizing power is from top to bottom oxidizing power decreases. So F2 is greater than Cl2 is greater than Br2 is greater than I2 is the correct option. T-shaped interhalogen compound is CIF3, ICI, CIF3 or IF5. The correct option is this is a structure of ClF3. So ClF3 is the T-shaped interhalogen compound. So A option is the correct option. Fluorine react with water to give HF and O2, HF and OF2, HF and O3, HF, O2 and O3. 2F2 plus 2H2O giving you 2H2O giving you 2HF plus O2. 3F2 plus 3H2O giving you 6HF plus O3. So HF, O2 and O3 are the correct option. Fluorine is stronger oxidizing agent. This is attributed to many factors except heat of dissociation, reduction potential, ionization potential or heat of hybridization. Hydration. The right option is ionization potential. The acid which cannot be kept in glass bottle is HF, HCl, HBr, HI. HF react with glass bottle, so that why HF is not cannot be kept in the glass bottle. So HF is the correct option. HF is not stored in the glass bottle because it reacts with the visible part of light. It reacts with the sodium oxide of glass. It reacts with aluminium oxide of glass. It reacts with SiO2 of the glass. The correct option is it reacts with SiO2 of the glass. The high oxidizing power, if F2 is due to high heat and of hydration and high heat of dissociation, high heat of hydration and low heat of dissociation, low heat of hydration and high heat of dissociation, or high electron affinity. Fluorine having high heat of hydration and low heat of dissociation, so second option is the correct option. Correct order of boiling points of hydrogen halides is from top to bottom. Boiling point increases, but due to hydrogen bonds, HF has more boiling points. So HCl is less than HBr is less than HI is less than HF. So third option is the correct option. Which one of the following halogen acid is a liquid? HF, HCl, HBr, or HI? The right option is because of hydrogen bonding, HF exists as a liquid state. So HF is a correct option.